Good day to everyone who is just now logging on to join us for the third installment of our Controller and Coffee webinar series, where we'll be focusing in on the topic of delivering APIs in real time with API management. My name is Florence Dula. I'm a product marketer on the NGINX team, and I'm joined today by a great group of panelists who are here to share some insight on the controller offering in terms of API management, as well as cloud automation orchestration. Before we get started, I'm just going to ask the folks that have joined us so promptly, thank you very much, but why don't we give just a couple minutes for additional folks to join on the line. So sit tight. All right, one other thing that we will do while we're just waiting for some folks to get on the call is we're going to go ahead and start with a warm up. And we're going to warm up with a poll that focuses on a piece of coffee trivia. So just want to make sure all of you out there do have your coffee mugs or tea mugs in hand, as I do, and make sure that your vehicle for interacting with us during the entire webinar is working properly. So with that, I'm going to launch the first poll, and that is approximately how much does the average American spend on coffee a year? Is it $800? Is it a cool 1,000? Or is it a hot 2,000? Go ahead and click on that, and we'll see just how many of us get the answer correct. Great, 30 more seconds on the poll. Yeah, those answers are coming in fast and furious. All right. I'm going to end the poll at this stage and share the results. Congratulations to the audience. Largely, the attendees, 41% of us, got the answer correct. Indeed, according to multiple sources on the internet, which is always true, the average American spends $1,000 a year on coffee. And the interesting follow-up to that is that number does have some significant variance when you go into different age groups. So millennials out there in the audience, you spend way more money on coffee a year than $1,000. All right. So thank you for participating in that bit of fun. I'm going to stop sharing the results here. And I'm going to ask folks to pay attention to your Zoom screen, the bar at the bottom of your screen or the top, depending on where you put your settings. And just let you know that there's a Q&A button there that you can use to submit questions at any point in the webinar. This is more of an informal sharing out that we'd like to have with you. So no need to wait until 45 minutes or 30 minutes in to submit a question. If a speaker is presenting something that you want to ask a question on in real time, please feel free to submit that, and we'll do our best to address it there. All right. So let's move on to the next. Wanted to introduce our wonderful panel this morning. I'm joined by Karthik Krishnaswamy, who's a product marketing director for NGINX, as well as Liam Crilly. He's a product management director. And then also Nina Forsyth. She is a senior product manager. And across the board, this team is one of the best sources of knowledge that you will have direct access to insofar as understanding some of the greatest challenges and solutions to address those challenges as it relates to API management and cloud automation. Welcome, everyone. How's everyone this morning? Yep, excited? Wonderful. Okay, so now you know a little bit about us. We want to know a little bit about you in turn, members of our audience, so that we can better tailor the content given what your main responsibilities are at each of your companies. So with that, I'm going to launch the next poll. Please share with us what best describes your main job responsibilities at your company. Do you focus on application development? Or do you focus on API development, implementation, and/or management? Perhaps you are a cloud architect responsible for taking that all-up view of the cloud systems in place. If you are responsible for driving, initiating, and funding digital transformation efforts, perhaps you're a C-level exec. And another possibility, if you are one of our DevOps audience members, please let us know. NetOps, infrastructure ops, and security ops. Great. So panelists, I'm going to go ahead and share what the results look like so that you can take a look. Can everyone see the results here now? Yes? Okay. So it looks like, oh, we've got a great variance across the board of, and representation across the board of various responsibility areas. DevOps being the largest group represented at 24%, but not too far off from that. We have app developers with good representation at 20%. Panelists, you got that docked in? You ready to go?
Yeah, thanks, Florence. It's a good broad overview of various sorts of folks that are developers, DevOps, IT ops. We have representation from all of those folks. Great. So most of you may be already familiar. We are very well known NGINX as a web server. In fact, we are the #1 web server on the planet and a popular reverse proxy as well. But what you may not know is that we are also a commonly deployed API gateway based on a survey of both our commercial customers and open source users. Many organizations are using us to manage API traffic, and we have drawn inspiration from this use case, this pervasive adoption of NGINX as an API gateway, to build a full lifecycle API management solution. And that's what I'm here to talk about, and so is Liam. Before I do that, before I talk about our API management solution, let's talk about what's driving the need for this huge adoption of API gateways that I just talked about, right? Organizations are undergoing significant disruption. Some of your own organizations may be undergoing digital transformation efforts. Enterprises are adopting digital transformation initiatives at a rapid pace based on the survey that we have, based on the information that we have, and provides them a huge competitive advantage. That's great, but beyond just competitive advantage, almost close to two-thirds, consider transformation essential for business, essential for survival, especially during these times. And modern applications play a very big role toward the transformation. Let's talk about some principles that are guiding this transformation. Cloud plays a central role. Building for the cloud provides for speed, scale, elasticity. It also offers moving data center CapEx to OpEx, and 87% of our customers are adopting not just one cloud, but multiple clouds. DevOps methodologies, they gave rise as a response, brokering the developers building the apps and the operator teams that need to protect the app and the enterprise. And according to IDC, 65% of organizations will expand their DevOps methodologies into the wider business by 2021. And this can be a heavy lift via ticketing systems. Automation and speed to market are still, they still reign supreme. 70% of our CIOs will use APIs to interconnect automation tools by 2021. And all of this is also driving the adoption of containerization in terms of underlying infrastructure changes. APIs are becoming the foundational building block as a way of developing modern applications. As you see from the information on the slide, 83% of all internet traffic is now APIs. So Liam, these are some of the trends that we have gathered, right? Do these trends resonate with customers that you've been speaking to?
Yeah, absolutely, Karthik. I mean, yeah, these trends are great data from a number of different well-respected sources. I speak to a lot of customers, especially around API management, and really in particular, it's the automation use cases that stand out to me as something which is really quite different over the last 12 months or so. So I see cloud, containers, and just getting wrapping your arms around these sort of technologies. You can't do it without automation. And that's really where I find that being able to manage any app or API with some sort of automation tooling is absolutely essential. And I guess I'll come back to this when we look at the demo, but we take an approach that we're not opinionated about automation tooling. We just recommend that there is some, right? What we want to do is integrate well with whatever tooling you have in place. So for me, automation is really key to success in actually making these modern apps, modern API-based apps really sing.
Thank you, Liam. Automation is definitely central to the initiatives that we are driving, that our customers are driving, and for us to support that. In that context, right, let's talk about how sort of APIs power modern applications and practices. Enterprises are modernizing their apps by adopting microservices-based architectures. These services, to Liam's point, they are usually containerized workloads. Kubernetes, one of the most widely used container orchestration platform, that's widely used. Microservices, APIs play a central key role in microservices-based applications. Microservices entail lots of APIs or lots of API gateways. With respect to cloud native aspects, the application components of the various microservices are networked together using APIs. Developer optimized refers to reducing the friction so that application teams can build the apps quickly. And finally, the point around automation, API management sort of needs to seamlessly integrate with DevOps workflows, automating build and deployment processes for their apps and APIs as well, not just the apps, but as you're exposing APIs and the underlying as well as the deploying infrastructure as code, API gateways that are needed to process the API calls to eliminate the manual errors and achieve sort of a consistent configuration. That's where infrastructure as code comes in. So all of these huge transformations, from modernizing apps to deploying the underlying infrastructure, requires APIs and robust API management. So we have to take a different approach to how we build and manage applications with sort of this API first mindset. Here's a poll question on the consumption of it, on the number of APIs that you plan to manage over the next 12 months.
Thanks, Karthik. So if everyone can see this poll, if you could let us know, are you planning on managing 1 to 10 APIs, 10 to 100, or over 100? We'd love to hear it. Okay, just a few more seconds for folks to respond. And here we go.
Wow.
Karthik and Liam, looks like lion's share, over 50% of our attendees today are looking at 1 to 10, and then a third are looking at 10 to 100. But there's a wealth of volume still represented in our audience today, 50% at over 100.
Right. So NGINX and Big IP data plane components are very versatile and fulfill every use case, as you see in the slide, needed all the way from code to customer, right? You can use NGINX Controller to manage a variety of NGINX personalities, as I call it. Today's topic is, of course, API management. NGINX Controller helps you to define, publish, secure, and monitor these APIs, essentially a full lifecycle API management solution as you introduce new APIs that you're planning to over the next 12 months. You need a control plane to define the lifecycle, apply policy, provide visibility into what's actually going on, and that's what the controller does. Now I'll hand it over to Liam, who will go over the architecture of our API management solution and follow up with the demo.
Thank you, Karthik. Okay, so I'm going to get a little bit more technical around the architecture of our NGINX Controller solution for API management. And looks like we've also got enough time. I'll try and squeeze in a live demo just to keep things really exciting. So here's how we view the major components that you need to deliver a full lifecycle API management solution. And so per the previous slide that Karthik showed us, we've got API management. That's a lifecycle administration function, right? So you have the APIs, they're defined by either by the API owner or the developers, and we need to get them published, right? The other end of that line is the actual runtime code, where the development team have actually deployed the runtime infrastructure that's actually going to handle the traffic. And so what we do with Controller is that we have the controller is where you use either the UI or our API, and this is where we can take these DevOps processes. We can take in existing API specifications like OpenAPI, Swagger, and so on, and we drive those into Controller. And Controller knows about an API. It knows about API, it knows about versions, and what it does is that it takes the APIs that you have, the policies that you want to apply to that runtime traffic, and it expresses that as configuration on an NGINX instance, right? The NGINX, that popular open source project that's often used as a reverse proxy, is automatically managed by Controller as an API gateway. And of course, we could have lots of gateways. So you can deploy in a micro gateway pattern, or you can deploy in an edge gateway pattern. We're very not opinionated about the style of your API deployments. The other big component here, of course, is a developer portal, right? So it's no good having an amazingly efficient runtime environment and an API gateway that handles your API clients and gets the requests to and from the runtime if no one knows that your APIs exist, or no one knows how to consume them, how to write applications, client applications that consume APIs. So that same API definition, that same API spec gets augmented and gets represented for humans on the dev portal and for computers on the API gateways. And then of course, those API runtimes might be running in containers, they might be running in Kubernetes, they might be running in a cloud environment. We really don't care too much about what that runtime is. NGINX is already perfectly well suited to being an API gateway and a reverse proxy for any of those environments. So that's kind of the landscape and the high level mechanics of the individual components that make up our overall API management solution. So one of the key tenets about the way that we architect our products is that we make sure that data plane and the control plane are entirely decoupled when it comes to runtime traffic. So when an API call comes in, we make sure that the API gateway is fully capable of handling each and every request in a fully autonomous way. So there is no dependency from the API gateway to the control plane for any of the requests it's processing. If it's doing authentication, if it's doing rate limiting, if it's doing complex microservices-based routing, the API gateway has all the information it needs, all the configuration it needs, excuse me, to handle that traffic, and therefore we do that in the most efficient way possible. So as Karthik says, we've been helping customers configure NGINX as an API gateway for a good number of years, a very popular use case. What we take with Controller is we have a view of an API lifecycle, and we automatically configure our API gateways with that best practice knowledge in a way that is easy to automate, at the same time minimizing any latency that we're introducing by putting an API gateway between a client and the traffic. And so if you were to compare us, for example, with some older V1s, API management solutions that were born in the sort of SOA, XML, SOAP, WSDL world, they tend to be more tightly coupled, and a request might need to be processed in combination with the API gateway and the management layer. And that, of course, is a very expensive thing to do, especially when we're talking about microservices, when you've got lots of little discrete API calls. So that has a couple of benefits. The performance benefit I already mentioned, that the other benefit is that we can deploy API gateways far and wide. They don't need to be close to our control plane. You can put our controller solution with the control plane in your data center and put API gateways across the multi-cloud environment, across multiple regions, and they'll quite happily process traffic in a very efficient way and report back, right, in terms of metrics and logs back to the control plane in a timely fashion, but there's no runtime dependency. So that gives us a lot of flexibility about architectural and deployment patterns that customers want to adopt. So let's cover some of the architectural elements. Really what I want to spend most of the time doing here is taking you through a quick demo of kind of what this looks like when you're actually using the product. So, and I'm going to pop a Brave pill, and I'm going to do this live. So let me switch to my web browser. I'm logged into a controller instance. This is a fairly empty system, so there's not a lot of data flying around, but I do have some APIs already set up in here. So if I jump to my services, and the first thing I see is that controller is an app-centric product, and that means that we care about the apps that you're delivering. An API tends to be part of an overall solution. Usually they're not isolated APIs. They can be, and that's cool, but ordinarily they're in support of some other business function. And so in this case, they belong to apps. And in my case, for this demo, I've got some subscriber services, which you might see in my mobile app, and I've got sports results. So that's our business, right? We're going to sell sports data or give access to sports results data. They're my apps, and if I click on one of these apps, my sports results, I can see that I got some sports stuff already configured, like tennis, baseball, and so on. Let's double click on that. I'll jump into the API section, and here I have the individual list of APIs that are currently being published on the system. You'll see that each of these has just one version, but that's not really common. So what I'm going to do is I'm going to publish version 2 of this F1 Formula 1 API, and we'll kind of work that end to end. So this is what it takes to publish an API with a sort of production spec configuration with our solution. So the F1 results API currently has one version, so let's add a version to that. And I can import this with an open API spec, or I can configure it manually. What I'm going to do is I'm going to paste in a spec I've already got. So let's jump to my text editor. I've got an open API specification here for version 2 of my F1 API. You can see it's the usual kind of YAML kind of configuration. So I'm just going to copy that and paste that in here. Right, it's already picked up that it's version 2 from that spec, so I don't need to do anything else here. Here it's pulled in all the resources, which I can edit if I wish, but my spec is good, so we're going to submit that. But that's only half what we need to do, right? So that's an API spec, and I might publish that multiple times. So an API definition is not the same as a published API. An API definition might come from your engineering team. It might not have any security info in it, right? So what we need to do is we need to take this V2 spec, here it is, and we're going to publish that. And this is where we link the API definition to our runtime environment. So let's go ahead and do that. Version 2 is what I'm publishing, so let's call this F1 V2. And here is where I do that connection. Here's where I do that plumbing. So it's going to be in my prod environment. It's going to belong to my sports results app, and I'm going to publish it on my primary API gateways. And this, as you can see, is kind of decoupled from that infrastructure. You might have someone else responsible for deploying the API gateways. There might be 1 or 2 or 10 or 12 API gateways that share this traffic. I don't need to know that. I just need to know that I'm going to publish it on my production gateways. Now, most of the work we need to do is actually comes down to actually routing each of the endpoints of my API spec to the backend runtime infrastructure where it exists. And so for that, we talk about components. So let's do that. So my components here, this one is going to be my F1 backend components, and I'm going to define my backend. These are containers that actually run them. So I have backend workloads, right? And in my case, I've got a couple of containers. So I'm going to add the URIs. So there's container 1. And I'm going to have, I'm pretending this is prod, so I'm going to have 2 of these. So that's container 2. Then I can choose to be more sophisticated and use service discovery. I can choose which load balancing method I want to use. So there's lots of the sort of typical application delivery controller load balancing capabilities that we might want to adjust here. But I'll keep this fairly simple because what's maybe more interesting are things like doing rewrites. If I need to patch a bad spec, people are making API calls to the wrong endpoint, I need to fix that. I can do that with a rewrite. But let's make this a little bit more production-like and enable a couple of security protections. So first off, rate limiting. Let's key that against an authenticated client because we want to make sure, this is not a public API, this is for our subscribers and consumers. So we'll key that each authenticated client gets a very generous 1 request per second so that I can actually demo this. And I'm going to reject anything that's over that limit, but I can, as you see, I've got some options around what my behavior should be when I exceed my rate limit. Let's keep that simple. What else am I going to need for security authentication? So let's add authentication requirement. And let's pick an identity provider. I've got some set up already. I'm going to use one that my local IDP that I can actually generate tokens for. So that's this one. And let's make sure that we send the API key, the JSON Web Token in this case. Let's send that as a header. And the header is going to be called x-jwt. Right? Okay, so there's my authentication requirement. I could do some more sophisticated conditional access, like say, oh, and my JOT claim needs to include a certain value to be allowed to access this. But let's just keep this as a basic authentication requirement. I'll skip the advanced stuff, but I wanted to just mention the API spec. And on every bit of the UI, and I've been focusing very much on the UI for this demo, everything that you do in Controller, we have this API spec. So it shows you, if you want to automate what I just did here, here's the API endpoint, here's the API payload. Use this to bootstrap your automation. So go through it once, grab the API specs, template those in your tool of choice, whether it's Ansible or a bash script or Postman, whatever you want to use to automate things, and then you don't have to do that again. So everything you see in the Controller UI is built on API calls, and we show you what those API calls are so that you can automate them too. All right, let's get that submitted. So now I've got a backend. I've told it my 2 containers. I've told, I've got a couple of policies for security, and now I can start routing these API endpoints onto these containers. So I might have a container for each of these services, right? It might be microservices. In this case, I'm going to just drag over a few of these endpoints. Let's do all the drivers endpoints. Sorry, I'm zoomed in here. And what else have we got? Drivers. There's another one. Right, so I'll leave some of these unrouted. Again, there's the API spec for what I just did. And let's submit. And now I've got 2 versions of this API.
Wow, Liam, that's pretty slick.
Thanks, Karthik. Right, let's see if this works. Okay. Right, I'm going to switch over to my simple API client, otherwise known as Shell. And I published this. So I'm going to use this to pretend to be an API client. I published this to my sports.example.com endpoint, and if I hit that, yeah, that is not a valid URL. I like to get the basics. There we go. Right, I've got a 404, right, because I didn't publish anything there. I published something to API F1 drivers, and I think I need to put driver ID. So let's choose also. All right, different error, unauthorized. And I didn't supply a token. So let's get a token sorted. I've actually got a makeup of a token here. So what I'm going to do is turn that into an actual job. There it is. Let me just grab that. So let's make this API call again, but now, was it x-jwt? Let's paste that in. Now I got a 200 OK. Now I've got a response. Let's repeat that a few times, 3 times. And I think I've got either a rate limit or something not exactly working. Okay, let's put that down to a live demo glitch. And the last thing I want to show you is the dev portal. Oh, there it is. Wow, I think this is just Zoom killing my computer. So right, we got a response, and then I got told I got my 429 response, right? So it is working, but my laptop is slowly dying. All right, so there we've just published an API, a second version of an existing API with a rate limiting and with authentication requirements, in a few clicks. And that's also, by the way, load balancing to 2 backend containers. So quite a lot packed in there. I know I was going super fast. And the last thing that I wanted to show you was what this looks like on the dev portal. So dev portal is already set up. It's at devportal.example.com.
And what's the purpose of the dev portal? Like, what would you expect like a normal customer to want to use dev portal for?
Yeah, great question. It's got 2 jobs primarily. First job is, well, what APIs are actually available to me? So firstly, I've got my sports results APIs and my subscriber services APIs. So with the same, they belong to the same apps, the same app-centric view that we've had of things in Controller. So job 1 is, well, here are the APIs that exist: baseball, F1, golf, tennis. So I got an inventory of the available API catalog. The second thing that I want to do with this is jump to the API I just published. So version 2 of F1. And for each of these endpoints, I get to learn how I actually make an API call. So we do a few things here. Of course, we take what was in that API spec, which had the endpoints, right? It had just had these parts. And I add that to the host name where I'm publishing my APIs, so that when I go to API F1 drivers, I get to see what it actually takes to make a request to this API endpoint as it's published right now. So we augment that runtime info with the API spec to give something to developers that's genuinely useful so they can actually write code. And of course, we'll give them some samples as to how you might make each of those API calls, including sort of description. Everything that was in that spec, any help text, and mine's pretty minimal, is included. So when we jump to the post, it's a create a driver entry, right? Not many words, but we get to see what APIs are available and how we should consume them. So there we are. So we publish an API. We actually publish it twice. Once to the API gateway and once to the portal. And that's handled automatically. So there we go. Whirlwind demo. And I think with that, Florence, I'll hand back to you. I think we should have another poll to be looking at.
Yeah, actually, before we move on to the poll, we had a question from the audience, Liam. Someone spotted a really cool icon in the UI there. Could you speak a little bit to that?
You mean like my these are emojis?
Yeah.
Emojis. I love emojis in demos, and of course, any good web application supports emojis and full Unicode support. So why not use it? I mean, even the NGINX syntax supports Unicode. So you can use them safely and anywhere. And yeah, when it comes to just like driving to the front page of the portal, it just makes things just a little bit more interesting. So go ahead and use emojis. Knock yourself out.
So Liam gives you our audience members full green light to use your emojis. Go crazy.
Oh, and of course, use emojis as fav icons. That's my other top tip here.
Okay, thank you, Liam. Karthik, I'm sorry, did you want to add something?
I just wanted to I think you have amazing branding as well.
Okay, thanks. All right.
Yeah, of course. This is just an indication that of course the portal is fully brandable, right? So we don't have time to go into that. But you can change all the colors, all the fonts, all the icons.
Well, nice to know it's customizable. Okay, why don't we go ahead and launch a poll at this time? Liam, thank you for being so brave as doing a live demo. Maybe next time we'll give a brave pill to your computer too. So I'm gonna launch this poll. If you folks in the audience can let us know what elements of the demo you thought were most valuable, or even to aspects of the API management offering that we weren't able to demo today just because we're short on time, but that Liam spoke to, that would really help our product team in helping to ensure that our product roadmap will be of the best service to you. So importing existing API specs, was that the most interesting, most valuable to you? Versioning of APIs, microservices routing, Kubernetes integration, security policies perhaps, automated deployments, or the dev portal? I'll just give another 5 seconds here.
You can click them all if you like.
Yes, that's right. Multiple choice, select all that apply. All right, let me go ahead and end polling here and share the results. Liam, look at that. Basically everything that you've either mentioned or shown has value to our customers. Versioning of APIs edged out just a bit at 38%.
Yeah, it's interesting. Some nice even spread.
Yeah, very nice. Seems like appreciate the audience response here. Validation that we're on track.
We'll keep doing these things.
Mm-hmm. And on that note, I will actually make mention, if you are interested in having an even stronger influence on the product roadmap, then make sure to speak to your NGINX specialist or your F5 seller account manager and let them know that you'd be interested in seeing a trial, experiencing a trial, and then even perhaps being a participant in a proof of concept. Okay, I'm gonna stop sharing results here. And at this stage, I would like to invite Nina to talk to us a little bit about cloud orchestration and automation. And thank you, Liam and Karthik, for speaking to us on API management.
All right. So a little bit about cloud orchestration. I think there's going to be a poll right now from Florence. We'd like to know kind of what your cloud investment looks like right now, where your most of your apps are located. So if you could go ahead and fill that out.
All right. Choices are, for those of you who are eager to help us understand where your investments are: AWS, Google, Azure, VMware, IBM, Oracle, or Alibaba. And give you another 5 seconds. All right. Nina, overwhelmingly.
Okay. Yeah, perfect.
Okay.
So AWS being at 79%, followed by Google and Azure. Not terribly surprising from what we've seen. And VMware in there somewhere. So that's good to know. So it looks like we will at least demo something that is interesting to everyone that voted AWS side for most folks. So let's go ahead and talk a little bit about what some of the challenges that we are trying to solve with Controller. So a couple of things, we're trying to automate your pipeline. So we're going to be able to deploy Controller and your instances automatically within your pipeline through Ansible or other scripts of your choice. The ability to understand and manage your app portfolio with pretty fancy analytics, which I will demo today live, hopefully. And then lastly, the one that I'm really going to show off is that you'll be able to empower your teams with self-service. So the ability to deploy a new instance automatically without having to call the local DevOps team or IT in order to get a new application. And so the idea being able to speed up your automation and your team's efficiency. So, so here's some of the features we have for multi-cloud support within Controller itself. So we support every application and API in the cloud. So we saw the API side from Liam, and we can also do the application side, which I will walk through. We can deploy Controller in any cloud, anywhere, and it's just an application running within Kubernetes. You could fit up Controller in a public, private cloud, manage instances, either public, private. There's no limitation on where you want to put your applications or where you want to put Controller itself. And then finally, a new feature that we have coming out it came out in 3.6, is that NGINX can now manage, or NGINX Controller can now do a full cycle management of NGINX instances running in AWS. So we can launch and also destroy instances within AWS without calling your local DevOps team. So let's go ahead and we're gonna do a live demo. And I don't have Brave pills, but I have a Brave beverage. So this is NGINX Controller. This is the slide or the screen you get when you log in for the first time. So we're gonna walk through how you would configure your new integration. So when you go to platform under integrations, there are, I have already pre-configured this just because there's some sensitive information included on here, and I don't want you to steal my keys, but so this is what it looks like when you want to configure your integration. So this would be something the DevOps team would already do. They would set up their access key and secret so that the team is able to make add new instances without having to know all the infrastructure around AWS. So once we have that configured, I'm going to switch over to using the API actually. So after we've configured the integration, let's go ahead and log into Controller. So we're logged into Controller now, and if I wanted to, I could also list the integration here. So we can see down here the access key, the secret, and then the link to that integration. So let's go ahead. The first thing we have to do is actually create a location, and the location is going to tell Controller things like what VPC you'd like to configure this in within AWS and what region. So the VPC and region are the two locations in question for here. So let's go ahead and send this through. So we have sent that on, so we can check the UI just to make sure it shows up. So we have Washington as a location right here. And so there's my VPC in my region that I just configured. And we have no instances configured because we have a couple more steps to go, but they're pretty simple. So let's go back to the API. So again, if I wanted to do a list on it, you would see the full full location. Oh, this is the wrong one. So let's do. And here's my location I just created. So next up is something called an instance template. And the instance template is even more fine-grained as far as features go. So as far as objects go. So in this case, we're going to actually configure an AMI. So the AMI within Amazon is Amazon Machine Image. And it is going to be something that is supported within Controller. So this one case is in Ubuntu, and it does have NGINX Plus pre-installed. It's actually, this is the marketplace image. You can select any instance type that you'd like, as long as it's supported within your region. And then the subnet ID within your VPC, your security group ID. So you would want to have the ports open so you could connect to it, or you know, open on port 80, 443, anything like that. and then your public key that is stored within AWS. So let's go ahead and send this through. So check over here. We have the instance template created here. We have all the information that we sent over. So now we're ready to actually create an instance. So, and in a perfect world, the DevOps team would set up location and they would set up instance template. And then the app developer come in here and they could create their own instance. So when you create an instance, you have a couple options. One is add an existing instance. So if you have one that is already running NGINX Plus and you just want to add it to be managed within controller, you would select this option. We're going to go ahead and do this option because we have a new one we want to add. So we're going to use the location we created, the instance template we added. And you notice there is only one in here. That's because the location is tied to the instance template. And so we're going to go ahead and submit that. So right now, here's my AWS account that is logged in. We're going to reload here. And so now we can see the AWS instance is initializing. So this will take a few minutes. And so I've already created another one called AWS Oregon, which I will walk through some of the new graphs that we have available. So when you have the instance created, these graphs will start populating data. You'll be able to see the basics around the instance like memory, CPU, and throughput. And then once, in this case, I have an app configured. So once the instance is up and running, you'll be able to create your gateway and your app. And if you go into here, you can see your latency of your app running, how it looks compared to the previous day, or even more granular than that, you can switch to an hour. And so this app I've had up and running for about a day or two and sending some light traffic through, so you can see how it's doing. And it has pretty reasonable latency there. So let's go back and see how this is doing. It looks like it's up and running, so they're just doing some status checks now. So we should be able to go into here and see the instance running. It should be green now. So we can see that the status is that it's up and running, agent has connected, and we should start getting data within a few minutes. So I think that is about it. So that's the demo for this part. So we'll go back here. I did record it, so just in case, but luckily we're able to pull off a live demo, so that's exciting. Anything else you wanted to add, Florence?
No, I just think that was really powerful. Twofold reasons. One, just the aspect of that self-service capability. I think that was huge. So thanks for showing that to the audience. And then the other is just how quickly everything could be done, right? Even within.
Yeah, it's impressive. Yeah, I mean, the time waiting is really just AWS getting the instance up and running, which is still, it's an impressive amount of time that it takes.
Yeah, exactly. So well done to the team. I think at this stage, why don't we give our audience some tips on how they can learn more, because as much as we would love to spend more time with you all, our time together this morning is only capped at an hour. So if they were interested in learning more about Controller, whether it's the aspect of delivering real-time APIs, or if it's diving deeper into cloud orchestration, Nina, where could they go?
So F5 University is a great resource for learning about all things NGINX, and I have taken some of their classes even before they were part of F5, and they are awesome. So they wanted to let you guys know that they are moving to a new location, and so they will be soon moving over to the Learn F5 side of the world, which also has some really awesome classes around Big IP and other functionality that F5 makes. So this is a great place to learn about Controller, and be given that we have updates to Controller on a monthly basis, the Controller classes are also updated on a frequent basis.
Great. Well, thank you so much for that. Appreciate it, Nina. All right. Why don't we go ahead and we have a little less than 5 minutes left with you and our audience. So I think, what better way to wrap up than to ask our panelists one last time, with all of the wealth of experience that you've had in the industry, not just working on, the controller solution, but just having conversations with customers about what their roadblocks are and their really like the speed bumps along the way, as they're looking to deliver real-time APIs, as they're looking to scale their apps in the clouds with ease and speed. What is a practical tip that you can offer them? Either perhaps something that they can make sure to do or make sure to avoid doing. And I'm going to start with, let's see, Karthik.
Sure.
Would you like to share what's that one piece of advice?
Sure. What we've heard from customers is actually our solution, the API management from NGINX, is especially ideal for internal APIs, as enterprises sort of unlock data silos that may exist within organizations. If they use a traditional Gen 1 API management solution, like Liam was pointing out, it's cloud-based. Bear with me here for a second, because the actual call because of the tight coupling between the control plane and the data plane that may exist with Gen 1 tools, the call has to be going to the cloud. Even for an internal call, internal API call, it has to go to the cloud, which is circuitous, not performant, and not secure. They have to punch holes in the corporate firewall to be able to allow that communication. With us, what people are finding out is you can, of course, deploy the gateway, any platform, controller, any platform, on the cloud, public cloud, private cloud, on premise, and there is not this. It's not closely tied. There's no tight coupling, so you don't have to go to the cloud to process internal API calls. So I thought that's a learning that we've had from our customers, where they've found it really useful, our solution.
Okay, great. Thank you, Karthik. Liam, insights that you can share with our audience? One tip?
Yeah, to touch on the DevOps angle here. So for those of our DevOps community on the call, if you're looking at deploying APIs, my advice is it's a little bit different to how we used to deploy web apps. And that really comes down to there being multiple owners, more stakeholders than we're used to dealing with. So my advice is identify where the API definition comes from, who owns it. Sometimes it's DevOps, but often it's the dev team. And so understanding the flow of where that API definition or that spec, where that source of truth is for that spec is really important. Because it might also go through a documentation team, right? It gets quite complicated. So you really need to understand the flow and the canonical source of truth for the API definition itself. And the second thing is you need to understand who's responsible for the security. Is it you? Is it security team? How much of it comes from knowledge the engineering developers have, and how much of it is based around centralized governance? And that's an angle we see people getting tied up in knots over, where we've got this new microservices distributed application, but we can't do centralized governance because, well, all the API gateways are doing their own security policy. So think about who owns security, because that's going to have an impact on how you do the automation. Where does that API spec come from? How do the policies get layered on top? And then how do you weave both of those things into one pipeline? And if you need to break it down into those steps, and that avoids you running into rat holes or getting data from the wrong place. So identifying owners would be my top advice.
That was absolutely spot on. Thank you, Liam. And Nina, what
So I
was
would say, yeah, I would say Liam sort of stole mine, which is around security. I definitely think as much as you can automate the security, the better off you are in the future. Especially with controller, there's kind of a out of box is secure, and then you can add more to it to even make, if your company requires additional security measures, they're available in the product out of the box, it's also a secure product. As far as like deploying of instances in the cloud, you get to pick your AMI. That means you get to harden it to yourself. You get to make sure all the ports that you don't want open are locked down. You get to select your security groups so that you can lock those down also. So we're providing you a lot of things out of the box that, while are secure, you can make it even more secure. And as much of that as you can automate is always better in the long run.
Okay. Thank you so much, Nina. All right, so we are approaching the close of the hour. So I just wanted to thank the audience again for joining us. We have just a couple of housekeeping items to review before we log off. Okay. So wanted to remind folks, you may have seen this in our social posts as well as our email announcements, but we do have a promotion ongoing today. And actually this is the last webinar that would qualify you if you were to, now that you've attended, if you were to also trial and activate the controller product that can be reached through our website, nginx.com. Just look on our webpage here and click on request a free trial. If you do that by the 12th of August, then you'd be entered to win a gourmet espresso machine that is in its aspects very much like controller. It has a light footprint. It is fully automatic and it is easy to use. Apologies for those of you who are not US residents. This promotion is only you're only eligible for this promotion if you are a resident of the US and meet the age requirements. But for everyone in the US who, even if you don't trial and activate, we just do want to say thank you for joining us today. Keep an eye out in your email boxes for a promotion code that will allow you to get your own version of our awesome controller coffee mug. And then just wanted to wish you all a good rest of your day. Really, really enjoyed having you with us. Bye, everyone.